we have a polynomial equation here. You see that equal sign? It means equation. And they want three things from us. They want us to list the possible rational roots, right? Remember that roots and zeros, you'll see those words interchanged. Then they want us to use synthetic division to find one actual root. And then we're going to take that root and we are going to solve the equation. Okay, so there's different ways to do this. If you can factor the whole thing, that is a quick way to do it, but they're asking us for these three things. So let's go ahead and do that. And so to find the possible rational roots, we need to take a ratio of the constant term, right there, 45, and the leading coefficient. And if you look here for a coefficient, I don't see one, so we know that that is understood to be the number 1. So we learned this, called it the rational zero theorem, but I guess in this case it will be the rational root theorem. And I called it the PRZ, the possible rational zeros. I'm going to keep that notation. And we're going to list all the possibilities of the constant term over the leading term. All right, so the constant term, it is 45. Our possibilities are 1, 45. Let's see, 2 doesn't go into 45. Let me get my calculator. All right, 45 divided by 2 gives me back a decimal, so that doesn't work. 45 divided by 3 is 15. 45 divided by 4 gives me a decimal. That doesn't work. 45 divided by 5 is 9. And then 6, 7, and 8, I don't think those are going to work. 45 divided by 6, nope. 47 divided by 7, nope. And 45 divided by 8, no. Okay, here are the numbers that I'm going to use for my numerator. All right, now put them right there. Now let's list all of the possible factors of my leading term, which is 1, and that can only be 1 and 1. So we will put them all over 1. And we know anything over 1 is just going to be itself. So let's sum it up right here. The possible rational zeros are going to be plus or minus 1, plus and minus 3, plus and minus 5, plus and minus 9, plus and minus 15, and plus and minus 45. Okay, so you have a positive possible and a negative possible. That gives us, let's see, 1, 2, 3, 4, 5, 6. That gives us 12 possible rational roots.